Assalamu alaikum, everybody. This is Dr. Shahid, and we are actually preparing ourselves for chapter number 3. This is from Anderson, Sweeney, and Williams, and this chapter is about the numerical measurements, which is a very important area of descriptive statistics. So, in this presentation, I'm going to explain the measures of location. Some of these measures are also called the measures of central tendency. Then I'll be discussing the measures of variability. You know, variability is a very important aspect of statistical data that needs to be investigated and examined. Then we'll do the measures of relative location, and we'll be detecting some outliers as well. EDA will follow. These first four topics are univariate. They're all for a single variable. But the fifth topic is going to be about the measures of association, and this is going to be between two variables. Finally, we'll have a discussion on the weighted mean, and we will see that how weighted averages or weighted standard deviation or variance can be computed from a data set. The chapter has many formula. I'll be sharing that with you. And at the same time, there are exercises that needs to be looked into. That again, I'll help you with. I'll be sharing some of the material, some of the exercises I'll solve, and I'll share them with you. So let's start with the measures of location first. Recall, we had this discussion in the class. Data is either qualitative or quantitative. Quantitative data was either on a ratio scale or an interval scale. So whenever the data is quantitative, we have to compute an average for the data. These first three measures of location are also called the measures of central tendency because they identify the center in a data. So how can we know this as a center of the data? Because we have to see the spread of the data. So if, let's say, this is my data set, I just need to hit the center here. So the middle value is usually called the center. So this is going to be my average, and this is the rest of the data. So you can see that the data is variable. If I have another data set, let's say this one, so hopefully this is going to be the center. Okay, so I beg your pardon for this drawing. I'm not very technical with all this stuff, but I'm just trying my best. So this is the average. But if you take a look at the variability in these two data sets, averages may look the same for two data sets, but variability may be different. I mean, this has low variability and this has a high degree of variability. You can see the spread is quite huge. Okay, so we may have curves for them as well. Like this is a normal curve. So in a normal curve, average comes right in the middle. So whenever you have a normal distribution, a single variable, the mean, median, and the mode, they're all at the same place. And why is that? Because arithmetic mean is the center of this scale. So if I'm taking this line, this baseline, and I take a middle number, this is going to be my arithmetic mean. But if I take the middle value of this curve, so the mid of this curve, and if I place a value in front of that, that is going to be the median. And the mod is always the topmost observation. So the top here right now is again at the center. So mean, median, mode, they're going to be the same for a normal curve or for a normal distribution. Instead, if I have a positively skewed curve or if I have a negatively skewed curve, the averages are going to be different place. So imagine this is the peak of the curve. So this should be the mod. And the middle of this line should be the mean. That's right the center of this. I mean, take a scale and measure it. This is the mid of this scale. So this is going to be the mean. And if you take half of this curve, so the half of the curve is maybe here. So half curve on this side and half on this side. This is the median. So what is the relationship now? This is the mod, this is the median, and this is the arithmetic mean. And in this curve, it will be a reverse of that. So this is the mod, this is the peak, the mid of the curve is the median, and the mid of this scale is the mean. So this is how the relationship goes for these three averages if you're in a normal data or an abnormal kind of a data. These two things, they're called the percentiles and quartiles. Actually, they are from one family, and we call that family quantiles. So there are a number of quantiles or fractiles that we compute. They can be quartiles, they can be percentiles, and there's a third in the family as well. They're called the deciles. Okay, so now let me just clear all of this. Let me just erase all of this. And if we can have an idea of the percentiles and the quartiles here. So let me just take again a data set. So let's say this is my data set. Okay, this is the data that I have. So data could be ungrouped or grouped or ratio or interval. It could be any kind of data that you have. But imagine this is in order. So the order is increasing. So small number is coming here and the highest number is coming here. They are all arranged from left to right. Imagine left to right. So if I'm finding the quartiles comes from quarter. Okay, quarter means 1/4. So 1/4 of this data set should be here. 2/4, that's half, should be here. And 3/4 should be here. Now, this is quartile number 1. Okay, and this is quartile number 3 at the end. This is quartile number 3. And this one is quartile number 2. That's in the middle. So the first quartile comes at 25% of the data, the second quartile comes at 50%, and the third quartile comes at 75% of the data. So these are observations. The values placed at these percentages or these positions are going to be the quartiles. So this is how we identify the 3 quartiles. So please remember, quartiles are 3 in number because they divide the data in 4 equal pieces. So you can see the data that we have is in 4 pieces. So that's like 1, 2, 3, and 4. Data is divided in 4 parts. So these values are in the data that are identifying a location at 25%, 50%, and 75%. Similarly, if the same data set we want to divide in percentiles, so imagine now you want to have not 4 parts, but you want to have 100 equal parts. So like before, when you wanted to have 4 parts, you computed 3 measurements. This time, if you're going to have 100 parts of the same data set, maybe you have to compute 99 measurements. So that's like, this is the first percentile, this is the second, this is the third, and this is the 99th percentile. So percentile number 1 comes here. That is going to be the 10% value, and percentile 99 comes right at the end. Okay, percentile 1 is, sorry, at the 1% of the number, and P99 is the 99%. value. So hopefully you will get 100 parts of data if you compute 99 percentile. So that's like 1, 2, 3 up to 100 parts. So that's the concept of percentiles and quartiles. Mean, median, mode, please remember, they're always reflected at the center of the data. If the data is normal, of course, they can be to the left or to the right if they are not normally distributed, like I told you in the previous slide. So this was a little conceptual understanding of the percentiles, quartiles, and uh, the mean, median, mode. I hope that you will understand it better once you read the book. So after this, if you take a look, the next slide shows that the three averages that we were talking about, that how are they computed, what kind of data can be taken for them, and what advantages or disadvantages they carry. So if you take a look, arithmetic mean, that's the simplest average. This is usually taken as a sum of values divided by the number of values. It has a simple formula that you can have. It is done for ratio or interval scale data, and it is sensitive to extreme values. So, I mean, the other good things about an average is very simple, can be computed for any kind of ratio, interval, scale, and this is the numerical center of the data, and the sum of deviations from the mean is 0. Okay. Um, so, but it is also sensitive to extreme values. So there are some good and some bad things about it. But that's the most commonly used uh, average or locational measure for descriptive analysis. The other two are the median and mode. And now you can see median is a middle value for the data. That means that um, it will not be exposed to the large variation of data on either ends, to the left and to the right. But the data level, you can see it can be computed for ordinal data sets as well. So partly for qualitative data, you can compute a median. It is the middle value. Uh, that's it. So arrange the data in increasing order and identify the middle value, and that is your median. That's not sensitive to extreme values. Okay, but at the same time, it is not using all information. It does not use information from all the data. Just taking the middle value, and that's it. Mod, on the other hand, is the most frequently occurring observation in the data set. Okay, so take a look. This can be done for any kind of data, both for qualitative and quantitative data. So that's an added advantage. Okay, but it may not exist at all with some data. If it is not repeating, if none of the number is repeating, there is no mod of the data. Okay? And it may not reflect the center at times. There can be, I mean, there's a possibility that data has two mods, maybe more mods. Okay, so these are a few basic things about mean, median, mode. Obviously, you have to go through the book in order to understand them better and put yourself in some of the examples. I'll be explaining these concepts by taking formula and taking some questions from the book, but they're very simple. I'm sure you will get them easily. Okay, so the next thing that we're going to study is that how to compute it from a data set. So let's take a look at this data set. This is about monthly rental values for one bedroom apartments. This is from some city or some country. It's like imagine this is a hypothetical data. So the sample is of 70 apartments. Okay, and the data is quantitative. As you can see, these are in numbers, and this is about rental value. So the data is on ratio scale. These are dollars, and the data is already arranged. So 70 observations are arranged. So what we are going to do with this data, we have to compute the mean, the median, the mode, and obviously identify some quartiles and percentiles from this data. The first one is going to be the mean. Very simple. So this is what I was telling you when we were looking at the previous slide. You have to sum the data values. So you sum the data values. So the sign that you use for summing is summation. Xi means there are many x's. I denotes the subscript that the number is from 1 to 70. X is the variable, and that is actually the rental value. So X denotes the rental value, I denotes the number of data values. So there are 70, and this is how the formula emerges, divided by the number of observations. We had 70. Now you can see we are using this latent symbol with bar. So X bar is summation Xi divided by N. X bar is for a sample. Mu is for a population. There is no difference in the formula, only the signs are changed. So instead of small n, sample size, we put a big N, capital N, which is for the population size. This Greek sign is for the population indicator. So whenever you see Greek signs with some of the indicators, with some of the findings, imagine they are for big data sets, in the inferential sense, of course, if you're considering inferential statistics. So this is how mean is going to be computed. Let's do it now. So sum all the numbers. The sum of all these numbers is 34,356 and divided by 70, which is 70 observations. So the average rental value is 490.80. Okay, so this is the numerical center of the data, the arithmetic mean. Let's do the median now. Now, what is the median? Median is basically when it's the middle value, but you have to arrange the data in increasing order. So that's the main thing that you do. Okay, you can see all these statements. Observations could be odd or even, but that's common sense. If I have 5 numbers, let's say if there are 5 numbers, 3, 10, okay, and 11 and 13 and 16. How many numbers do I have? 5. This is 13, sorry. And they're in increasing order. Where is the middle number? This is the middle number. This is my median. That's it. If I have even observations, even number of observations, so let's say I have 4 observations, 2, 6, 7, and 9. How many observations do I have now? 4. So where is the middle value? Here is the middle value. But you see there is no number in between. But I can average these two. So the average of these two is 6.5, sorry, not 7, 6.5. That is my median. So this is how we identify the median. Now, sometimes a rule is used, and let me show you that rule. Okay, so the rule that we are going to use is, okay, the rule is this. Actually, median is also the 50th percentile. That's the middle value. This positioning rule could be used to identify the median. Now, what is this positioning rule? This is I is equal to P by 100 into N. Now, what is P? P is the 50th percentile. Median is the 50th percentile. So you put 50 here by 100, that's 0.5. Multiplied by 70. What is 70? Number of observations. So what do we get? We get 35.5. That's the average of 35th and 36th value. So let's go back to our own example. Okay, I um, when I was doing it with 5 numbers, I can put 5 here. So you can see that I will have for 5 data value 3, 10, 11, 13, and 16. I will have 0.5 into 5, okay, which is going to be 2.5. Now I have 2 and 5. Now I cannot take 11th. Can you see? I mean, if I use the same rule, let me just write it down for you. I is equal to, sorry, let me select a pen first. Yes, so I is equal to 0.5, which was 50 by 100, multiplied by the number of observations I have. I have 5 observations. So this is going to be how much? 2.5, right? 2.5. So 2.5 should be between 2 and 3. Okay, but that is not the median actually. Is it? No, it is not. So the rule is, the I rule is, whenever you get a number with a decimal, round off the number. So if I round it off, round off, sorry about this, I can't write using this. So if I round this off, what will be the number? Third. Okay, because the point is 5. If it was 4, naturally I would have taken second, but this is 0.5, so I will have to take the third number in the data. So what is the third number? 1, 2, third. So now I've gotten my median. Imagine if I had this situation where I had 4 observations, 0.5 would have been multiplied, or we'll have to multiply 0.5 with 4. What do I get now? I get 2. I cannot take the second number. I know by definition this is not the middle value. So whenever I is an integer, I this time is an integer. When I get an integer, I have to take this and the next number and take their average. So whenever 2 comes, you have to take the third number with it and take their average. So the average of 6 and 7 has to be 6.5. So that is the little rule. This is written in the book as well. And I hope that you get it. If you don't, please tell me, I'll explain it again. Okay, so let me just rub off this thing. Okay, this will take a few seconds. Okay. Yes, and let's proceed with the remaining presentation. So I gave you a basic idea that how can you use the rule. Recall, I just told you, if you're getting a non-integer value, if you take any non-integer value, you have to take the average of the 2 numbers. Okay, so the median, no, wait. Yes. Yes, so because you have to round off, so the rounded figure is 36th value. You can, because they're the same number, so you can take the 36th value even, and that will be the average. So the median in this case is 475. If I would have had 35th number, then I would have taken the average of the two. I don't know why they have done this here. So using the rule, we will find an exact number. Anyhow, the third thing that we are doing is the mod. Now, mod is a value that occurs with the greatest frequency. Uh, if I have one mod in a data set, that's unimodal. If I have two mods, equal frequency for two observations in a data set, that's bimodal. And if there are three or four mods in a data set, that's called multimodal. Some observations may not repeat themselves at all. Such a data where none of the observation is repeating itself, the mod will remain undefined there. So in our data set, as you can see, 450 has the most frequencies. So that means 450 is the mod. Okay. Now recall, I gave you a concept a few slides back that normal distribution has the mean, median, and mod to be the same. But in this data set, what do you think? Is the mean, median, and the mod, are they the same? No, they're not. So the mean is 490.8 and the median is 475 and the mod is 450. So let me just write these three numbers for you, okay? So that, and let me ask you a question. One average is 490, 490.8 or 7, I don't remember. It was, let's go back. Yes, 490.8, sorry. So 490.8 point 490.8. The second average was 475. And the third one is 450. So the first question is the data normal? Yes, it is not normal. The second question is it positively skewed or negatively skewed? How can you answer this question? Yes, so you have to make a curve for it. Let me see if I have space on the next slide. If I can go to the next slide. Yes, I have space here. So before we do percentile, let me explain. This was the mean, this is the median, and this is the mod. So let me just draw a line for you that will tell us, okay, so arithmetic mean comes right in the middle of the scale. So this is actually 490.8. Okay, done. Which is the next number? 475. Now 475 should come to the left, isn't it? So 475 should be somewhere here. This is the median. Okay. Now this is the median. And the last number is 450, which is below all the three. So I have to take this somewhere here, 450. So now you can see, and usually, not usually, always, mod has the highest frequency. So this is the highest frequency. This is top of the curve. So that means the peak of the curve is here on both sides, and this comes down like this. Okay, so you can see now this is positively skewed. So only using the idea of mean, median, mode, we can decide about a distribution, whether it is skewed. Okay. So I hope you get this concept. let us now get the idea of percentiles. Now, as I've told you before, that's a very important measure for some colleges and universities around the world, where they'll place the test results of a student or the grades of a student on percentile score. So they put you in a percentile of student. Are you in the 60% percentile or the 70% or the 80 or 90%? Okay, and this is where most of these students are scoring. So you're kept in that group. So percentiles is basically a data set that will be divided into 100 equal parts. Okay. So percentile, again, using the same rule, we can identify percentiles. And you can see this rule is explained here. If I is not an integer, round up. And if I is an integer, then take the average of that value and the next number. So this is what I explained it already to you. Data should be in ascending order. So if I imagine, if I'm working out a percentile, the pth percentile maybe 10th maybe or 20th maybe. So I will take the 20th percentile to be 20 by 100 into the number of observations. If I'm taking 30th percentile, then it will be 30 by 100 into n. So hopefully an I value will come up for a particular percentile. It could be for a quartile as well. You know, the first quartile should be 25th a 25% value. So P should be 25 for quartile 1. For quartile 2, it should be 50. The second quartile is also the median, and it's the 50th percentile. And quartile 3 should be 75 by 100 into n. So from this I, some value will pop up, and that value will either be an integer or not an integer. If it is an integer, you have to take the average of the position I and the next number. And if it is not an integer, you have to round up the number. So that's a simple rule you have to follow with the data. Okay, let's apply this rule here. So 90th percentile is to be worked out for an ascending order data set. Is the same 70 observations, the 70 rental values which were taken. So 90th percentile will be 90 by 100, 70 is multiplied, you get the 63rd value. So 63 is an integer actually. You have to have the 63 and 64 value. 63rd is this, 64th is this, take their average. You get a 90th percentile, which is $585. Okay, now what does this 585 would mean for us? This 585 would mean that 90% of the data in our distribution is below $585. 10% of the values are above $585. So you can see this 10% is to the right and this 90% is to the left. So that's the concept of the 90th percentile. Quartiles, I just told you, are the 25th percentile, 50th percentile, and 75th percentile values. We can do that very easily now. Let's do the third quartile first. So in the rule, you have to put 75 by 100 multiplied by 70. This is a decimal number, meaning this is not an integer. Whenever you're not getting an integer, you have to round up the values. Round up 53. 53rd number is 525. What is the concept? 75% of the data is below 525. 25% of the data is above 525. Similarly, we can do the remaining two quite easily. Okay, so this was the whole discussion. I'm not going to start the measures of variability right now. I just finished 5 very important measurements with you, and they were the mean, the median, the mod, the percentiles, and the quartiles. And the measures of locations. Hopefully, they are done. I'll be explaining. You should refer to the book first, and I'll be solving rather some questions from the exercises of the measures of location, and I'll be sharing that with you. But they'll be shared in hard form. You have to look at them. You have to remember the concepts that I've discussed here in this presentation with you. And if there are any questions, then and you can hopefully um, raise them when we face each other on Google Meet or Zoom. Thank you very much. Bye bye.